So yeah, today I'm going to talk about how we migrated from encrypted shared preferences to DataStore and how we did it securely in KMP. So that's me. I'm a mobile developer in Umain. I used to be a QA, but now I do Android and KMP development. So first of all, about the agenda. First of all, we're going to talk about why do we need the migration. I'm going to explain what encrypted shared preferences is, why do we move to DataStore and FlowSettings, and what are the alternatives to it. And then I'm going to talk about the tech, how to implement DataStore, what is FlowSettings exactly, and why I'm going asynchronous. Then encryption, I'll explain a bit why later, why do we need encryption, and I'll talk about Tink and schemas and security. And then obviously why we're here today, migration plan, and how we did the migration, how we planned the migration, and I will show the real code that we used to do it. And then the aftermath, what we learned, what you might encounter if you will try to follow us with the migration. So let's get into it. First of all, why? Why do we change something that already works? An obvious question, but pretty simple answer. Encrypted shared preferences was deprecated by Google in the beginning of this year, and when you visit the Google page of it, you just see that this class is deprecated, not supported anymore, and Google advises us to use shared preferences instead. Why don't we use shared preferences instead, you might ask, and why bother switching to DataStore? Short answer, shared preferences has no KMP support. And every modern app that we're creating today should have KMP support, in my opinion and in the community's opinion, obviously. So, and DataStore is just better, and let's dive into why. So, long answer. First of all, as I mentioned, FlowSettings, which I'm going to talk about a bit later, makes DataStore usable on both Android, iOS, and also desktop. I haven't tried it myself, but according to the documentation it does. Then also it's modern and reactive. It's Kotlin, flow-based, asynchronous. Obviously, because of those three things, it fits both Compose and KMP and Compose Multiplatform. And it's safer, it's transactional. Since it's transactional asynchronous, it avoids data corruption and also does not lock the main thread, which makes us safer and also faster. It's future-proof, shared preferences, even according to Google, even though they recommend it, but it's still, even according to Google, it's deprecated and it's legacy. So we go for DataStore, which is supported both by Google and by the community. So yeah, then for the alternatives. First of all, why do we even need shared preferences? What is that? That is something that we use to store data in between sessions. We might store it in memory, but we need to keep it between sessions, so we need something lightweight to store our data in between. And also, it needs to be pretty simple to access the data easily, so we need just key-value relation. And we don't really need the relation between data. So what do you usually store in shared preferences or in DataStore? It's like some session data, it's tokens, headers, some light user info, probably user ID, some timestamps. So it's data which you don't have to have relations between. So why do I talk about relations? Because the obvious alternative to shared preferences for DataStore is a local database of your choice, Room or SQLite. It has pros to it, obviously. It has structured queries, has transactions, everything that database provides you with. But it also has relations. But for our particular case, we don't need, and it's an overkill for us because we just need simple key value. And also, if you go for local database, you need to support schema migrations. You will stuck in the main thread at some point, and you don't need this complexity for lighter data, as I mentioned. And obviously, it lowers the app startup, and also, judging by experience, causes a lot of memory leaks. So, and second option that you can go for is custom file storage, JSON, Proto, choose your poison. But obviously, if you're creating something from scratch, you have the whole control over it. It's the only the only plus that I can think of, and there's a lot of cons to it. Because since you're doing everything from scratch, you need to parse the data and handle concurrency yourself, and also it results data corruption risk. Obviously, if you're doing something yourself and from scratch, you don't have the KMP abstraction to it, and you will need to think how to integrate it with reactive flows. So it's quite an overkill for us. That's why we go for a DataStore. So I mentioned FlowSettings already twice. It's something that is a combination of DataStore and multi-platform settings wrapper, which adds flow support to it. It makes FlowSettings. So about the tech, I'm just going to show how to implement it in the code, especially the DataStore. It's super simple. As you can see on the slide, obviously we're working with Android context right now, so we got to get the context. With the factory which the library provides, we create the file with our new name for DataStore, and we create an instance of it with the constructor that also library provides. And also I put the documentation piece here. The create method also takes in corruption handlers, migrations, scope, and produce file. So yeah, let's go further. So why encryption? It can be pretty obvious because, judging by the name of the presentation, we're switching from something that has encryption in the name to something that doesn't, and it's actually the case. DataStore doesn't have any encryption inbuilt. So we gotta build it ourselves in that case. And in this particular case, we're going to use Tink. That is a Google library for encryption. Why we're using it? First of all, it's a highly maintained Google library, and it's reliable, and it's been used for years already, and at the same time, it supports KMP, so we can use it. And here's the code. First of all, we get the context, since we're working with Android context here. And first thing we need to do is AED config, register the AED config. What is the AED is authenticated encryption with associated data. What is associated data? I'll talk a bit later. And what you need to do first is to create a key set handle. The key set that your data is going to be encrypted with. And it's like as goes on the slide. You first create your master key. You choose the key set template. You can choose your own, but this is the most common one, AES 256. It's a symmetric encryption algorithm that uses a 256-bit key to secure data. That's the most popular one, and we went for it. So then you just build your key set, and the most important part, you need to create the object which you will further use to encrypt and decrypt the data. So then you just pass the context and your new object to your interface of shared preferences for DataStore. So obviously, two main methods of DataStore is put and get. And we're going to go through them and see how we decrypt data here. And first of all, put. You use the object that we just created and passed, and use the encrypt function, and you pass the value, and you pass something that is called AAD, which I already mentioned. AAD is additional authenticated data. This is something that is used in the encryption algorithms to prevent something called confused deputy attack. For example, it can be a user ID, so another user having access to master key wouldn't be able to decrypt the data of another user because they will not have AAD. So it's another layer on top, which is used to encrypt data more efficiently. But in our particular case, we didn't need it because it's mostly temporary data that we don't really care about, and it's not staying actual for too long. So we went for just the empty string here. And obviously, you put the string into your DataStore. Then the get method, same thing. You get your string from your DataStore. In case you don't get it, you return null, and then you decrypt. You use the same set of parameters. Obviously, if you had AAD, you gotta pass the same AAD here to be able to decrypt the data. And you just put it to string, and that's it. So, why we're here today? The migration itself. And first of all, we need to define what is the migration for us. The migration is our case, so we need to figure out that it's not just switching storage providers, because we also have already data on user devices that we need to migrate. So we also need to migrate data of every current user to new provider and do it securely, obviously decrypting and encrypting on the go. And we also need to ensure that the new users that will going to start using our app also will use the new solution right away without affecting the user flow and experience. So, if you're doing a migration, first of all, you need to come with a strategy, and here's ours. First of all, you need to define the moment when the migration is going to be done. And in our particular case, we decided that it's going to be initialization, because every user that installs the app or just relaunches the app will go through the initialization flow, so they will surely pass the migration. And in your case, you can do it wherever you want, but that's our approach to it. So then do the migration, obviously consists of a couple of steps. First of all, check if the migration has been performed before. We don't want to migrate the user every time they launch the app. That will be slow and pretty stupid. So if so, we just skip the code that we're going to perform. But if not, we perform the migration. We care about our users, we care about their storage. So we delete the old data, and then, again, not to run it twice, we set the migration is done flag to true. Is that it? Actually, no. When planning the migration, you also need to plan accordingly when you're going to remove the code of the migration. Because real life experience, I saw code of some particular migration being in the code base for like 6 years. So every user, 6 years later, will go to the migration even though the old provider doesn't exist anymore probably. So yeah, let's see. Then, about the migration code. As I mentioned, this code will run during the initialization flow. And everything according to steps. First of all, we check for our flag, and if it's true, we just return. We just don't do anything, because that user already migrated. Then we need to access the old data, and we need then create instance of encrypted shared preferences. You can just, if you used it before, you can just reuse, just copy it over to here and get the instance of it to be able to interact with it. And then, very easy, you can just iterate through it using for each. And for every value that you get from encrypted preferences, you just put it in your new fancy DataStore. As I mentioned, we care about our users, so we remove the previous value from EncryptedSharedPreferences. And then, not to forget, we put the flag to done. So, for the aftermath, so we learned a lot while doing this, and I'm going to talk about why. So first of all, migration wasn't just a provider replacement, and it's like a mixed conception, because the API actually hasn't changed. It's still the same, like get, put, clear methods. So, but since we went asynchronous, it's changing timing and architecture assumptions. What was instant before is now asynchronous. And in our particular case, it not created, but exposed a lot of issues that we already had before. So it was really useful for our app. We really improved the productivity. We improved some flows, they became faster, and we also fixed some unobvious bugs that we had before. Also, async shift required client apps to evolve a bit, because when you're doing everything asynchronous, it's not mandatory to have flow observers and loading states, but we had to, all the legacy code had to go to flow and loading states. So, and secure storage is not just something that you just can plug and play. You gotta think about a lot of things. First of all, like what way do you want to encrypt your data? Do you want to encrypt your data at all? what key set do you want to use to encrypt your data, what configurations do you need, and also you don't need to do it consistently between Android and KMP. Also, don't forget about iOS. So testing was critical, as I mentioned, for us, and I'm sure for you too. This migration will make visible a lot of problems that we already had with timings, because everything will become asynchronous and fast, and you might encounter some UI issues, and not also AI, just architectural ones. So the outcome of it is like that we are now modern, reactive, safer, because we control the encryption. It's became more boilerplate. You need to manage the asynchronous flows more. There's like a lot of edge cases to it, but now you're ready for a multi-platform future. Thanks for your attention.
Good stuff.
Thank you.
Say it with developer.
No questions?